if our continuous map the inclusion of an open subset into a topological space, the inverse image sheaf under this inclusion map will be naturally isomorphic to the restriction of the sheaf. To prove this, we take an open subset of this U, and we compute inverse G of W. We first look at what is I pre-inverse G of W. By definition, this is a colimit of G of V, where V ranges over all the open subsets containing I of W. But I of W is simply W. And this will be equal to G of W. This shows I pre-inverse of G is equal to the restriction of G to the open subset U. And this guy is already a sheaf, which means it is equal to its sheafification. So we identified the inverse image of G under this inclusion map with the restriction of G to the open subset U. As we have shown at the beginning, the inverse image is a functor, and now we will show it can be an exact functor. Before proving this, let's first recall an important remark about taking stocks. That is, the exactness of a sequence of sheaves can be checked at the level of stocks. If we want to check a sequence of sheaves is exact, we can take the stock of sheaves and show that at any point the induced sequence of stocks is exact. Then we can conclude that the original sequence is exact. Suppose we have an exact sequence of sheaves of abelian groups, and we want to show the induced inverse image sheaves form an exact sequence. To this end, we take the stock of this sequence. But we know that these terms are naturally isomorphic to stocks at somewhere of F and G and H. If Q is equal to pi of P, then pi inverse of F stock at P is isomorphic to the stock of F at Q. And similarly for G and H. And furthermore, such isomorphisms are natural isomorphism, which means those squares are commutative. Now, since the original sequence is exact, we know this induced sequence of stocks is exact, which implies this sequence is exact. So, since this is true for all P, we know this guy is exact. And we are done. We can give a second proof of this. To show that pi inverse is exact, we show that it is both left and right exact. Pi inverse is right exact since it is left adjoint. And here we use the results in 1.6.12. Pi inverse is left exact by the following argument. Suppose we have a short exact sequence FGH sheaves of abelian groups. By exercise 2.5.f, we have a left exact sequence for any open U. And now we take the colimit. By the exercise 1.61k, the colimit over filtered index sets are exact. So we get this exact sequence. So I should have used V for open subsets in Y, U open subsets in X. Now correct it. Now we take the stock, the colimit again, and we get this exact sequence. And since the sheafification will preserve the stocks and the exactness, we get a sequence of stocks of the inverse image of Fg and H. So finally we will get the left exactness of this sequence of inverse images. So we have both the right exactness and left exactness. Here's a remark. Whenever we have proved a result for the sheaf of abelian groups, we always want to think about whether it still holds true for the sheaf of OX modules. And it is true for this case. And essentially the same argument will show that pi inverse, the inverse image, is an exact functor from OY modules on Y to pi inverse OY modules on X.